Hello students, welcome again to Purnang. So continuing with our questions of integration. So as you know, the purpose is to cover as many different type of questions as we can. Okay, to cover as many different types of tricks with minimum number of questions. Okay, so in that process, so let's start. Let's take up this next question where see we know what we have to prove because that was a proving statement. I just put it up as it is. So see. If you would have solved it, then I believe you know that trick. See, the point here is that if you have a combination of quadratic expression into square root of linear, again I am repeating, if you have a combination of quadratic expression in denominator into square root of linear term, whatever you have in numerator, that we will fix, we will see later. Okay. The first thing that you should try is to replace whatever you have within square root, the linear term, by some variable whole square. Why so? So that you can get rid of square root. Okay, so that's the first thing you should always try, and that's what I tried when I got this question, and then I found that I could solve it. Okay, so have that faith in on the person who has framed that question. Okay, so because normally we use it when there's nothing in the numerator, but then I thought to try it, so let's try it here also. So you will say, okay, I is, so x is t square minus 1, so plus 2 is t square plus 1, so that's what you get for x plus 2 in numerator. Dx is 2 times t times dt. Okay, and in the denominator, the quadratic term, as you can see, I can write it as x plus 1 whole square plus x plus 2, isn't that? So that's it, and this will be t and t gets cancelled. Okay, so now let us write everything in terms of t. One thing I will acknowledge that, okay, we shouldn't write both the variables simultaneously. Okay, so either I should have written entirely in terms of x, or I should have written entirely in terms of t, but since we know, see, JEE mains or advanced, no more they are theoretical papers, so I just took that liberty. But okay, I will say that I shouldn't have done that. Okay, so now replace it, so you get t raised to the power 4 here, plus x plus 2 is t square plus 1. That's it. Okay, now that's again, see, that was one form which involved a special substitution, a special case, and this is another form which involved a special method to solve it. Okay, so now let's move ahead. So therefore our integral is, I will take 2 out of integral sign, and then this is t square plus 1 upon t raised to power 4 plus t square plus 1. Now see, the denominator is a very special case. So whenever you have in denominator the combination of 4-degree term, quadratic term, and constant term, just these 3 numbers. Okay, these 3 terms, again the 4-degree term, quadratic term, and the constant term, what we do, we divide both numerator and denominator by t square always. So when you divide it in numerator, you get it as 1 plus 1 upon t square, in denominator you get it as t square upon 1 plus t square plus 1. Now see, the beauty of this form, basically the beauty of t square plus 1 upon t square is that you can write it in 2 forms as perfect square, t plus 1 by t whole square, and then this is minus 2. Okay, just by simply adding or subtracting the numbers, and then we can write it as t minus 1 by t whole square plus 2. Bachcho, which one to choose? Which one are we going to use here? That depends what we have in our numerator, because now you know that we are going to apply the method of substitution, the most special, most important method of indefinite integral. Okay, so here I will be looking for that form to which I will be converting it such that if I replace it with z, a new variable, I should get its derivative in the numerator along with dt. So what is it? So of course you can see that's this form. Okay, so now I will say let t minus 1 by t be z here. Okay, so therefore integral is 2 times 1 plus 1 by t square dt over, so I will be rewriting this in terms of t minus 1 by t whole square and that was plus 2, and earlier we had plus 1, so it will be plus 3 here. Now as I said, I will be replacing this by z, so once you integrate it, you get the term which you already have in numerator along with dt bachon. Okay, so now replace this entire thing by dz here. So once you do it, so therefore integral is 2 times, and this is dz, and this is z squared plus 3, whose integral is of course tan inverse of z by root 3. Okay, so just take 3 common, so you will have this 1 root 3 whole square, and then you have here 1 bachon, isn't that? So if I write again, see, I've actually, the problem here is I have to derive every time each and everything. Okay, so bear with me that much. So methods are important. These small results you always know. So it's 2 by root 3, and then this is dp over 1 plus p square. So it's 2 by root 3 tan inverse of, so dx upon 1 plus x square integral is tan inverse of x. So it's tan inverse of p. Tan inverse of p is z by root 3. So tan inverse of z, and z was how much? T minus 1 by t. Okay, and t, what was t? Okay, just a minute, I just missed it. What was t here? What was t? Okay, so t is root of x plus 1. Okay, so it's z by root 3. Okay, so let's do it one by one. Okay, so this by root 3 bachon plus c, and then you can replace t by x plus 1 under root of x plus 1 to get it. Okay, so I think that's what we needed. Yeah, almost the same, 2 by root 3 tan inverse of whatever. So you simplify it, I believe you will get it in that form bachon. Okay, so that was the question for today of indefinite integration.